give us some
Sure,
insights on
sure,
the
sure, sure.
indoor air quality. Uh, Give us some more insights on the indoor air quality, how it is important for our daily usage, where we are most of the time we are remaining in houses environment, especially in countries like Middle East. We are exposed to we are depending on the air quality of from the air conditioners.
Yes, true. We will do that. And if you don't mind, we'll just introduce ourselves first, our company first. Yeah. If you don't mind to
Yeah,
say that. Yeah.
we will have an introduction section once Dr. Kathy joins. She's here. I think she has joined, Kathy, and she's again on mute.
Hello, everyone.
Hi, Kathy. How are you?
Hi, great. Sorry, well, because previously somehow I cannot hear everything, so that's why I quit and rejoin. And seems like it's okay now, right? You can hear me. You can
Yeah,
hear
yeah,
me
I can.
also, right? Okay, that's
Yeah,
great.
we
That's
can hear
great.
you.
Yeah,
Because I can't hear you, so sorry about that. Some technical issues.
Yeah.
yeah. So, gentlemen, we will, since Dr. Kathy has joined the webinar now, I would like to make a brief introduction of Dr. Kathy Jim. She is a leading expert in the indoor air quality and sustainable innovations.
Yes.
She has spearheaded the development of nano-confined catalytic oxidation (NCCO) technology. It's a groundbreaking solution which enhances the air purification efficiency and longevity. Her leadership has earned RHT Industries international recognition, including the United Nations Sustainable Development Achievement Awards in Hong Kong in 2023. So we are happy to have you on board, Dr. Kathy, and also Dr. Mr. Sunil Raj Edwin, who is a very um, you can say a technical expert, having a very long expertise in technical sales, and he has spent 25 years of his uh, professional journey in 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 all the fields of mechanical. And we are also very happy to have Mr. Sunil on the board, and we will take forward our webinar. And I would like to just tell you about this webinar has been specifically chosen as in air treatment technology way for the indoor air quality improvements. So we would, through this webinar, we would like to educate all the people who have joined, and give a message to the team, to the engineers, and to the professionals, that how important is indoor air quality in our lives. What is the impact we are having on the indoor air qualities? Previously, also we had a similar webinar a couple of weeks before on indoor air quality. I have stated in the webinar that the indoor air quality in the previous webinar as well, a small case study for a school which has been done before and after the results have been taken in the mm, in a specific school in UAE itself, and it has been noted that the students have given a lot of production after the indoor air quality has been implemented, and there is a better environment. And also the students are feeling more energetic, and they are giving more results. And the teachers are also having a very great atmosphere, and there is a difference in their performance and in their lives itself. So that was one study which has been enlightened, and there are specific records on it that saying that how the indoor air quality is affecting the lives of the people and their productivity and their health as well. So I will not take much time, and I will hand over this session to Dr. Kathy and Sunil Raj Edwin. And at the end of the seminar, we will have a Q&A session. And also, we will also make an announcement for our next coming webinar topic at the end of this webinar. So Dr. Kathy and Sunil, the table is for you, and you can go ahead with your introductions and the webinar.
Thank you very much, Mr. Abdul Wajid, and good afternoon to all. Dear professionals who are gathered here in your respective fields, the professionals of your respective fields, it's a pleasure to meet and address you all today in this forum with reference to the topic, Innovative Air Treatment Systems. My name is Sunil Raj Advin from Binmusa in Delhi, Senior Sales Manager, Dubai branch. Our company, I'd like to share our, just a second. I'm sorry, I'm not getting the window that I need. So I'll just continue with my talk. Yeah. So our company, Bin Musa and Daly, was founded by our late Mr. Michael Frederick Daly with our local partner, Mr. Saya Musa, back in 1967. Today, the business is managed by our managing director, Mr. Michael Patrick Daly, and our commercial director, Mr. Luke Daly. We are the distributors of many major brands in the industry related to the MAP field, from pumps, RO units for offshore, valves for transmission lines, anti-corrosion protection systems for oil and gas pipelines, to name a few. We have more than 50 products in our portfolio. We have 6 showrooms spread across the United Arab Emirates with our head office in Abu Dhabi, with our well-equipped warehouses spread across Kazad, Alain, and Al Qusais, and feeder stores with all our showrooms. We also stock our products, the products for which we are the distributors of. We also have our production facility in Musaffa for the assembly of pump sets, and the operations are overseen by our Associate Director, Mr. Saul Godfrey. Today, we are going to present air treatment solutions from a company named RST from Hong Kong. Bin Musa and Delhi is proud to be the UAE distributor for RST solutions. It's a very innovative product where the air in our environment is treated by removing bacteria, viruses, TOCs, and also the product comes with a unique feature of odor control. A one-of-a-kind product in this industry. It has got NCCO filter, as Syed Wajid said, that's patented by RST, which has this unique characteristic of controlling odor. What is NCCO, and in what sense it is unique compared to the carbon filters and other media that is available in the market will be well explained by Dr. Kathy Jin. Mr. Syed Wajid has already given a short introduction of Dr. Kathy. I'll just continue on it saying that Dr. Kathy is the Director and Chief Technical Officer of RST Industries Limited. Dr. Kathy has attained, as Syed Wajid said, her PhD in chemistry from the Hong Kong University of Sciences and Technology. Dr. Kathy is a certified ESG planner, carbon auditor, and energy manager, just to name a few, I should say. Dr. Kathy has been relentless in her pursuit for the development of products related to the air purification sector. She's also the inventor of the NCCO filter. We are happy that Dr. Kathy is present here today to talk to us about RST solutions. So without taking any more time, I'll request Dr. Kathy to take over and let us know more about RST solutions and how it can help us, as Mr. Syed Wajid said, to attain better air quality in our environment. Dr. Kathy, please.
Thank you so much, Sunil, for the great introduction. It's so kind of you. So thank you so much for the opportunity today. It is really my great honor to have the opportunity to share with all of you about our technology. And can you, may I know if you can see my screen right now?
Yes.
Okay, that's great. So thank you so much. It is really a great honor of myself today to have the chance to introduce to all the engineers and professional about our technology. So the content or the theme of today is, of course, I understand that the whole environmental field covers a lot of different sectors, but today we'll be focusing on air quality. So the theme of today is the NCCO air treatment technology, which is a greener way for IAQ, which stands for Indoor Air Quality Improvement. So my name is Kathy, and I'm a PhD from the Hong Kong University of Science and Technology. I'm graduate in a PhD in chemistry. So Sunny already give me a very kind introduction. So I believe I'm not going to repeat it here, but I can share with you is that so our technologies was developed from the university around 2 decades ago, and throughout these 2 decades, we have been working very hard to commercialize and market this technology. So till now, we have established quite an extensive range of job references in Hong Kong, and because ESG is being a really hot topic recently, and our technology can really tackle into the ESG, because our technology basically can help to improve the ESG in a lot of parameters for some companies. So that's why you see I try to extend my knowledge in a lot of ESG and carbon reduction or energy management kind of things. And currently, I'm also the panel of the Hong Kong government regarding innovation and also energy advisory. So let's cut straight and to our topic. So I believe, because a lot of you are engineers, so I believe you'll understand that for all the treatment for air especially, so basically in the market, basically I can say that more than 90% of the product or system are using activated carbon. And so allow me to explain a little bit about activated carbon. So it is a porous material, so you can see it as a sponge. So the sponge, the carbon itself, will be able to absorb different chemical molecules inside the sponge. However, the carbon just do the absorption, and there is no kind of treatment done by the charcoal after the pollutants or the smell or the VOC, volatile organic compounds molecule, being absorbed on the charcoal. So that's why the lifetime of the charcoal depends on the surface area of the charcoal filter itself. So eventually, you will have to replace the charcoal. And we have done an extensive test in Hong Kong, and we have found that for Hong Kong, it's quite humid. When the humidity is high, so charcoal basically have a lifetime ranging from around 6 months to 12 months. And after all the capacity of the charcoal is being used up, so we call this state at a saturation. So after the charcoal get to the saturation state, it will start to have secondary pollution, which means that it will re-emit those pollutants from the charcoal back into the environment, which is bad, believe me, because you want to use the charcoal filter to treat the smell to improve the indoor air quality. However, if the charcoal is being saturated and if you don't do the replacement, it will re-emit back all the pollutants back into the environment. This is really worse. And as a user, you won't really know when the charcoal will become saturated. So that's why a lot of users basically just periodically change it every 6 months or every year. And the frequent replacement of the charcoal also cause a tremendous amount of solid waste generated. So that's why back in like 2 decades ago, around 20 years ago, our group of scientists would like to invent some technology which is more green, which is more sustainable, which is more efficient. So that's why our goal of inventing this NCCO technology is as stated in the title of this page. So we target to replace the activated charcoal. So a lot of people is pretty curious about the name of our technology. A lot of client actually asked me, "Hey, Kathy, why is the name of your technology so clumsy? Why is it called NCCO?" So because this technology was invented in the Department of Chemistry, and as a chemist, I believe you understand that we like to put everything in the name to make people that they understand. So the name NCCO is actually short form. The full name is called nano confined catalytic oxidation. And this is actually the mechanism of our whole technology. So basically, we are using some filter with nanoporous pores, and then we confine the air pollutants, the chemicals, the molecules into the pores of our filter. And then because our filter also have some like transition metal, which can have some catalytic event, and eventually we can have the oxidation, we can like oxidize all the pollutants. So this is the whole mechanism of our technology. As you can see on this page, you see some drawing. So this is the porous material. So basically, we have different formulation for this porous material. The formulation depends on what kind of chemicals that we need to treat. For example, is it like water-like, hydrophilic, or is it like hydrophobic? What is the size of the pollutants? Is it aliphatic or is it aromatic? What is the like physical or chemical properties? So after knowing the location or the like characteristic of the pollutants that we need to treat, first of all, we'll choose the correct kind of material, the correct kind of formulation to do the absorption first. So as you can see here, this is a brand new filter, and then our filter will capture the like VOC, volatile organic compounds molecules. So the first stage, it is similar to the function of active carbon. So do the absorption first to reduce the concentration in the environment first. And in order to tackle the problem of the lifetime, we will add some oxidant at the upstream of the filter. So we'll continuously add some oxidant into the pores by means of airflow, of course. So the oxidant will also enter into the pore. So now you can imagine like inside the pores, there's simultaneously the chemicals, the pollutants, and the oxidant. So allow me to discuss a little bit about chemistry here, but because time is limited, so it's quite preliminary. So the pollutants and the oxidant, even in air, they will have some oxidation reaction. And now I have already confined both things that originally have reaction into a very small like pores, and then with our catalyst, with the catalytic effect, the whole reaction will even be like easier, faster to proceed. So all the like VOC, the chemicals, the carcinogenic gas, etc., they will be decomposed and then oxidized into water molecules and carbon dioxide. So at this stage, a lot of people ask me, "Hey, Kathy, if your system can generate like water and carbon dioxide, does it mean that I need some like water pipe to drain out the water? Or does it mean that we'll need to increase the amount of fresh air in order to compensate the carbon dioxide?" The answer is no, because of the small amount of the chemicals of the VOC, we call it volatile organic compound. So the VOC is so toxic that normally for indoor, the concentration of CO of the VOC is in ppb level. So at most, which is really rare, 1 ppm. Let's say it like that. If for 1 ppm of the VOC, it is already like carcinogenic in long term. So if we convert all the like 1 ppm of the VOC into water molecules and carbon dioxide, it is just like 2 or 3 ppm of water molecules and carbon dioxide, which is negligible because for CO2, normally in air, it's like several hundred of ppm. And for water, the concentration is even higher, is in percentage. So that's why we can say after using NCCO, we can have negligible change of water molecules, of the humidity and the concentration of carbon dioxide in the environment. It's just like an additional person, like staying indoor, because at this moment, simultaneously, when I am doing the breathing, I'm also creating water molecules and carbon dioxide. So the amount of water and carbon dioxide generated by our system is like even less than the amount that I am generated at this very moment. So that's why it is negligible. So talking about the advantage of our system is that because we don't need that much replacement, and so that's why we are a eco-friendly technology, because we generate much less waste when compared to other systems. And we have a much long lasting performance, which means that you will need less maintenance. Because our technology was developed in Hong Kong, and Hong Kong is one of our major markets. And the manpower of Hong Kong is really expensive. So that's why a lot of our users would love to know that we can help them to reduce the amount of like manpower for replacement. And the whole maintenance of our system is really easy. It's just some on-site staff. We can do some easy training within 10 minutes. They can already do the maintenance. And talking about sustainability, because we do not use carbon at all. So that's why the whole like product carbon footprint is much less when compared to like similar products. So that's why we are a more sustainable technology. Last and not least, and I think this is also the most important thing, is that our product and our technology is safe. Because we can see there's a lot of different like air treatment technology available in the market. However, for some of those, for example, someone will just use like ozone generator to generate some ozone or iron in the air. However, for this kind of method, it is not the best, because like ozone, it has been banned in the US already. So for our product, we already got the CE, we already got the UL, and we also got the ETL, which means that we have proven report showing that we do not have excessive or extra amount of the oxidant that released into the air. We have accredited UL 867, and we have already got the CARB. So that's why safety is also one of the major concerns of us, and our technology is completely safe. And talk about the disinfection ability. So on this page, you see there are like 3 layers of filter here, layer 1, 2, and 3, from left to right. So air will enter from the left side and then first pass through the oxidant generator, which will oxidize the air by means of a little bit of like a voltage across the system. Hello? Why I hear something? Sorry, are you guys here? Because I hear some strange thing. Oh, yeah, I should be okay. Yeah, sorry. Let me
All
continue.
good.
Yeah. Sorry, I just hear, I thought I was being kicked. Sorry, let me continue. Okay. So first of all, there's the oxygen generator, and then the oxygen, along with the airflow, will pass through the HEPA filter. So the HEPA basically will remove all the particle, virus, and bacteria in the airstream. So for conventional HEPA filter, they can do this kind of thing. But for conventional HEPA filter, they cannot really kill the virus and bacteria. So that's why a lot of like operation staff will have the risk of being infected while they replace the filter. But for our NCCO device, because we already have the oxidant generator at the upstream, so the oxidant will also kill the virus and bacteria being captured by the HEPA filter. So that's why we provide an extra layer of protection to the operation staff. They don't need to worry about like being contaminated or secondary pollution when they do the maintenance. And this is also one of the reasons that the Hong Kong government choose to use our technology during COVID, because we provide an additional protection to the operation staff. And so the HEPA filter will basically remove all the like physical pollutants, the particle size. And for the gas, the smell, so basically it is the NCCO reactor, which is also the parts material that I showed on previous page to deal with it. So So that's why we don't call ourselves as air purifier. We call ourselves as air treatment system because our system can completely eliminate talking about like particles, um, biological pollutants, and also gaseous compound. And talking about the maintenance, so because our NCCO reactor on the layer 3, the porous material here, because we are self-sustained, we can continually do the decomposition. So that's why the lifetime of our NCCO reactor can be last for up to 12 years in our laboratory. And in some real case, for example, in some public washroom and in some garbage collection center in Hong Kong, we tell our client to check the status of the filter every 5 years, which, to be honest, it is like uh, already much longer than other like similar technology in the market. So to check it is to check whether if there's any like oil particle or fine dust being deposited on the surface of our NCC reactor, which may affect the overall like performance of our filter. And the second thing that you need to replace, and the second thing you need to do is to replace the dust filter, which is a HEPA filter every year. So that's why the whole maintenance is much easier when compared to other technology. And we have already received a lot of like report and accreditation worldwide. So this is one of the thing that I would like to point out. So during COVID, we have successfully find a lab, which is a DCC, Disease Control Center in China, to help us to do some like testing to prove that our product can effectively kill COVID-19 and different types of bacteria and virus. So there's a lot of existing technology in the market. Charcoal filter is one of the technology that I mentioned earlier. So the filter is used to filter away the contaminants from the air, but well, it is relatively high cost because you need to replace a lot, and the replacement is also quite frequent and generate a lot of waste. And the second way, if the engineer or the property management company do not choose to use charcoal filter, another way, basically they'll choose to use air change. And in Hong Kong, we have a lot of case that our client use excessive amount of air change in order to deal with the issue. Well, as a matter of fact, one of our project in Dubai is that in Dubai mall, because well, the mall is pretty busy, right? So the public washroom do have some smell. So there's some kind of like air change, and so that's why we suggest our client to reduce the amount of air change, because you can imagine for like in the Middle East area, there's pretty high temperature difference for indoor and outdoor. So if we use air change, it means that we are posing a lot of pressure on our ventilation system. You are wasting a lot of energy to achieve the air change. But if we can like do some simpler, easier method to do some internal circulation and remove the odor, which we can largely reduce the amount of air change in some premises, and eventually we can help our client to save money. And so that's why our product and our technology have been widely adopted in Hong Kong. So our client base include the government, for example, the Hong Kong airport, the Hong Kong government, the public, basically all the public washroom. The MTR is the most extensive public transportation system in Hong Kong. IFC is the most famous like financial center, the building of financial center in Hong Kong. Henderson is the biggest. It's like IMA in Hong Kong. You know, Henderson in Hong Kong is similar to IMA in Dubai. And we also work with a lot of like hospitals, elderly centers, like lab. Etc., schools, etc., etc. Because if you're talking about like air quality improvement or odor removal, basically you can find a scenario in like every place. So that's why we have pretty extensive kind of job references in Hong Kong. So because time is quite limited today, so I'm sorry that I can't really go deep into each of the job references. But I would like to show you here is that one or two of our project. So we do have a pretty extensive range of on-the-shelf product that is available. So this is one of the on-the-shelf product that we have. It is a ceiling cassette model. We call it the RH940C. So it is a ceiling model that you can like easily install, no ducting needed. So all you need is the power socket and like 4 screws to hang it on the ceiling. And the circular part here is the air in, the 4 slits on the side is air out. All the filter and fan motor is already included here. So the beauty of this model is that you can do a retrofit kind of installation pretty easily. So that's why it is also being widely used in Hong Kong. And for this photo, it is the one of the most busy public washroom in Hong Kong. So after installing our system, the odor inside this public washroom has been like greatly reduced, and the property management companies being really impressed by our technology. And apart from our like on-the-shelf product, we also do a lot of this tailor-made cabinet. So like currently, we are also having some client in the Dubai would like to add our filter system into their existing premises into their like AHU. So this is something that we can also help our client to design. So you can see here, that is our NCCO filter, and the filters that our client need to replace every year is the dust filter here. So I believe in the past, IAQ is not being like so, indoor air quality is not being so significantly like cared about. But I think, well, for HEPA filter to remove the dust, to remove the particle, it has been like known for pretty long time. But the smell, the VOC, is always the hardest part to treat. And for our technology, it is our strength to treat the VOC and the odor with the most minimal amount of replacement needed. So I would like to give you a brief introduction of our company. Our company is RHT. So we are a spin-off company from the most famous technology, Hong Kong University of Science and Technology in Hong Kong. So in year 2003, we are the major institute of indoor air quality, in short, IAQ testing company in Hong Kong. So we are pretty familiar with all the measurement and the certification procedure, etc. So in year 2003, we have filed the first patent of NCCO. Until now, we have more than 20 patents worldwide. And NCCO has also granted like multiple recognition. And we have been actively participate in different kind of exhibition to let more client and people know about our technology. For example, because we have a lot of different vertical sector. For example, we have our booth in the Pathology Congress for several years already, because pathology is one of the vertical sector that they need to use a lot of chemical solvent, including formalin, xylene. So our system is there to help to improve the occupational safety inside the hospital area. And we also have like other kind of like a building kind of exhibition, or the health or wellness or the eco or the innovation kind of exhibition that we'd like to know, let more people know about. And last year we were also at GITEX. Yeah. And so basically we have 2 brands that we successfully developed. So B-Mola is one of our domestic brand. It's like some like domestic type of air purifiers that you can put in your home. So we start to enter into the domestic market in year 2017. Until now, we already being listed on all of the like major retail sales channel in Hong Kong. And we already extend our retail market in China and other locations like Thailand and like recently with Musa Delhi in Dubai. And we are also the like bestseller local brand in Hong Kong since 2022. And for RHT, it is our commercial kind of brand, and we already have extensive amount of job references. So I'll be happy to talk to you more because time is limited today. But I'll be happy to talk to you more about each of our job references, our data, and our design, etc., etc. So basically, our job references include a garbage collection center, hospitals, public washroom. For a lot of public washroom, we have successfully helped our client to reduce the smell and to save like air conditioning at the same time, which is a one song, two bird kind of like result, which everyone is happy. So we also have some project in some data center because in Hong Kong, some data center is located in some place that the air quality is not so good. And we also have schools, elderly center kind of job references, and a gym. Because I believe Hong Kong, maybe Dubai is the Middle East is even more because Hong Kong is pretty crowded, it's pretty tight, and people spend a quite long time indoors. So that's why we always educate our client that indoor air quality is being really important. And for Dubai, I think people there or Middle East, I think people there spend like 90% of time indoor. So that's why indoor air quality is really essential because unlike like COVID, you get sick like immediately or the second day. But for indoor air quality, like the carcinogenic gas, the formalin, the VOC, etc., it is an accumulated kind of thing. So you won't get cancer tomorrow if you suck in some formalin or VOC today, but it is accumulated. So probably like after 10 years, it will affect your body, your health, etc. a lot. So that's why we have been actively promote the importance of indoor air quality throughout the 2 decades. And because ESG is being really hit in Hong Kong, China, and probably Europe. So that's why we are helping our client to achieve or to improve the occupational safety, to achieve some OSHA compliance, and well, to do some energy saving by using our system, and by saving energy, our client can also reduce the carbon footprint at the same time. So thank you so much for your time today. Please feel free to let me know if you have any question. Thank you so much. Hello? Stop. Yeah.
Thank
Thank you.
you, Dr.
Thank you
Kathy,
so
for
much.
giving a very insightful uh, view of the indoor air quality and its importance. With us, we have now Sunil. Do you want to put any more insights apart from Dr. Kathy, or what we will do?
No, I think Kathy has spoken about all the different applications that that the NCCO filter can be used at. So yeah, so now I think if anybody has got any questions, we can answer that.
We have with us Muhammad Faisal.
Mhm.
Uh, Faisal, he is also an indoor air quality expert, and we are happy to have him on board in this webinar. Faisal, I would like to take a lot of questions from you to directing towards Dr. Kathy.
Uh, I was really impressed with the technology. It's a very good product, I would say. It's really required for the market, and the one thing is, and obviously the nowadays the market is focusing towards a 360-degree approach. Maybe the technology on your product. You can add maybe a sensor display that could show the air quality of the product, air quality of the space as well, and that could add more live features on the product. This is my gentle input I would like to add. And along with that, you have mentioned UL 867 certification. So do the product has UL 2998 certification as well?
Thank you so much for your question. So first of all, we do not add the sensor inside our system, but for some project, we actually have a separated kind of sensor because our theory or our idea is that for people, we are not sitting at the outlet of the like air purification system. We are sitting in the environment. So that's why a lot of project of us, we installed like separated or individual kind of like air quality sensor, and then of course by some control system or some like control platform, so that our sensor will help to control the like on and off of our system, which we think the whole design is like a little bit better. So that's why this is something that we already have. And instead of like putting the sensor or the display on the machine, we put our user can check the data of the sensor through some like website or platform. So because for example, as a lot of our client is like property management company, so they don't want their site manager to walk around the site to copy the data. So that's why instead of like individual sensor, we create a platform so that the user or the manager can see the data like remotely. So this is the answer to number one. But very thank you for your advice and suggestion. And for number two, we do not have the UL 2998. Yeah, because currently I think for sales in the US and even in the California, UL 867 is enough, is essential already. And I just checked, well, some place they would like to like even a like better or more tightened kind of certification. But because till now we don't have any client that requests this kind of like certificate, and I believe there's a UL 867 has been used for like quite a long time and has been widely adopted. And CAR, we already got the CARB also, which means that our product can be sold in California. So yeah, so that's why we currently do not have this 2998. Yeah, thank you so much.
Mohammed Faisal, is it very important in this part of the world to have the UL 2998 certification? Is it part of any specification?
Yeah. So basically, ASHRAE, if you refer ASHRAE standard 62.1 as part of ventilation code, or if you refer ASHRAE standard 241 for control of infectious aerosols, UL 2998 is certification is mandatory. Because when you say UL 867 certification, so that is around 50 parts per billion is the product that's been listed. But when it comes to UL 2998 certifications, that's more stringent, as Kathy mentioned. So it goes till 5 parts per billion. So if you take a inkjet printer or if you take a normal printer, that will generate around 7, 8 parts per billion. So what ASHRAE standard strictly conforms to that to UL 2998 certification, so that like any electronic air cleaning systems, when it is doing an oxidation process, it should not oxidize and generate ozone as a byproduct, as Kathy mentioned. So that's why UL 2998 certification is getting mandatory these days.
Okay, thanks, Mohammed Faisal. Thanks. Okay.
Yeah, I would like to ask one more question. So when we say this carbon dioxide, do the NCCO technology targets the carbon dioxide? Does it helps in reducing CO2 level in the space?
We do not change the CO2 concentration in the space.
Okay. Thank you
We
so
do
much.
have here one more gentleman, Mr. Yasser. He's also an indoor air quality expert. Yasser, you would like to throw any insights to this webinar for the benefit of all the participants so that we can improve our knowledge on indoor air quality? Basically, the webinar is to educate the people on the indoor air quality and give us the insights what ASHRAE is telling, what like Muhammad Faisal has given the insights on ASHRAE, what ASHRAE is recommending, and what are the codes are telling, international codes, and what are the products available in the market, and what is the help we are getting through focusing on the indoor air quality. I would suggest a lot of the engineers who are doing the design to consider indoor air quality right from the concept design, so that it is implemented in the projects rather than having retrofitting is also one of the subject. Yes, we cannot change the existing scenario of the building, but the new projects always should consider indoor air quality as one of their fundamental points in the design. Yasser, please, if you can throw some insights, Yasser, please.
Sure, sir. First of all, Dr. Kathy, it was a nice seminar, very informative, and NCCO technology looks a very nice addition to the existing pool of technologies. My one small question is that how the oxidation uh, process takes place in your system, and secondly, if you compare with the plasma generation systems, which some air purification companies they are using, so how you compare your technology with plasma and how the oxidation is done in your system?
Thank you so much for your question. So I would like to answer the second question first. So for ionizer, so basically, I can say that our oxidant generation like is similar to like ionizer or ozone or ion. It's pretty similar. We have a electrode that we applied high voltage against it. So that's why I'd like to explain a little bit about our difference with ionizer first. So ionizer, you see, they use like the electricity, the voltage to generate the ion, so it's charged, so that's why it can like do some kind of oxidation. However, there is like extensive test that shows the ionizer, the ions basically because they have charge, so the major or the stronger point of thing is that it will mix the dust aggregate together, and when the density or when the weight of that aggregate become like high enough, that dust aggregate will like fall on the ground. So that's why if you use some kind of like ionizer unit in the environment, after some period of time, you will see a circle of dust around that area. So we call it the dust ring. So the dust ring indicates the distance that the ion can travel through. Because a lot of that kind of ionizer, they don't have fan or have a really small kind of fan. So that's why I think the disadvantage of ionizer is that it is probably better in some in like participating, like making the dust like drop participate on the ground, but you don't really like remove it. And eventually, you also need someone to clean the dust ring. So that's why I think the whole and talking about gas thing, because if you're talking about like reaction between two gaseous molecule in air, so it's pretty hard because you know the molecular distance between the two molecules is really far away. So that's why the whole efficiency for the like all the removal is relatively like low. We also have some tests done in the in the Japan by our client. So for our technology, although the like oxidant generator is similar to this ionizer, hydroxyl ion, or small amount of ozone, etc. Although this part is like similar, however, because we use a mineral porous material that first capture the volatile organic compounds, the VOC, and the oxidant at the same time. So that's why, well, our filter is actually just acting like a catalyst. It first absorbs the two things, and then it provides a site for reaction for the two things that already will have reaction in air. It's just we first capture them, we reduce the distance between the VOC and the oxidant. And because we also have some transition metal impregnated inside the pores of our filter, so with the presence of the transition metal, but the reaction between these two will be like much more easier and more like efficient. So that's why the whole like reaction, the whole oxidation reaction will be like more easier, and like the efficiency will be higher. So that's why I think our difference with the ionizer system is that ion, they don't have a like specific kind of like room or the site for the reaction. You just do the random kind of collision in air, which is like pretty hard. And for us, we confine the pollutants and the like oxidant, and then with the aids of the catalyst, the whole reaction will be more complete. So I think this is a like most major difference between us. Thank you.
Yeah, you're welcome.
Any
So
more
how, yeah,
questions,
how,
gentlemen? Sorry.
yes, I
Yeah, go
just want
ahead,
to add
Alex.
one more.
Yeah.
What's the, like, how you compare the lifetime of the carbon activated filter with your material? And can you give me a little brief about your material? What's that? How it's different from the carbon? Like, what's the components like? Just for basic difference
Okay.
of the basic.
Okay, yeah. So we have different like test report and job references. For example, for one of the like garbage collection center exhaust system that we have used in Hong Kong. So according to the Hong Kong government, previously they used water scrubber plus activated carbon. So they need to change the activated carbon 3 times every year. So which means that the lifetime for the carbon filter at that case is around 5 months, 4 months, yeah, 4 months, because 3 times every year, right? So because the lifetime of activated charcoal depends on the humidity and the concentration of the pollutants. So that's why I need to find an actual kind of scenario to explain to you. So talk about the same garbage collection center for charcoal. Their lifetime is like 4 months. And then for this case, we remove the charcoal and then put our NCCO filter inside. And then we have been using at the same site for 3 years already. And the removal efficiency of our system is still higher than 99%. So in lab, we have done a lot of tests in some confined chamber. So in lab, our filter can last for up to 12 years. Because as mentioned before, our filter actually just act as a catalyst for the VOC and the oxidant to perform the reaction. And the finished product, the water, the carbon dioxide, will leave the pores. And the contaminant to our filter is oil and dust. And in lab, there's no this kind of like oil and dust that will contaminate our filter. So that's why in lab, our filter can last for 12 years. And in actual scenario, we suggest our client to check the status of the NCCO filter every 5 years, because we think that, well, even you use the best HAPR, it can't be 100%, right? It's like 99.9999. So that's why we suggest our client to check the status of the NCCO filter every 5 years. And for the case of the garbage collection center, I guarantee the Hong Kong government, if they like, we help them to do the maintenance, right? We help them to change the dust filter. I guarantee them can use the NCC reactor for 5 years.
Thanks, ma'am.
Thank you, Dr.
Thank you.
Kathy, for
Thank you.
a very detailed explanation between the charcoal filter and the plasma and the ionization technology. And any more questions from the forum, from the attendees? Please go ahead.
Hi, Engineer Sayed. I just had 2 questions, if possible.
Yes, please go ahead.
Hi, Kathy. First of all, thanks a lot for the presentation. It was really wonderful and beneficial. So, Kathy, I just wanted to understand more about, I was having just 2 points for the confusion. The first one is for the maintenance, because from what I know, there are less technicians for the NCCO systems currently, especially if we consider in the UAE. So what is your opinion on this one for the maintenance part? If you can elaborate more on that.
Sorry, the internet just got cut a little bit. Do you mind to repeat the question? Sorry about that.
Yes. I had 2 questions, Ms. Kathy. The first one is regarding the maintenance part for the NCCO systems. So from what we know, that in UAE, especially if we talk about UAE specifically, we are having very less technicians now who can handle those systems, correct? If I'm not wrong. So in those cases, like, how do you recommend for the maintenance part?
Okay, thank you. So to answer your first question, of course, Bin Musa Daily is our trusted partner in the Middle East area, and for some of the project, even in Hong Kong, because I understand that for some project, they have some on-site engineer that they would like to do the maintenance by themselves. So that's why we can give them really easy kind of training. So because the maintenance of our system is basically to reset the timer that we remind the client to change the HEPA filter and to change the HEPA filter. So that's why I think any kind of like trained technician with our proper kind of training, they can easily do the maintenance. So that's why so I believe with our trusted partner in the Middle East area, we can like handle this kind of like maintenance. Of course, if client like to do it by themselves, we can do the training. And if client wants us to do it for them, we have our team locally.
Yes.
Okay, and just one more point, Mrs. Kathy, for the noise levels, for example, from what we know, that the NCCO system, for example, it normally creates more air resistance. For example, if we talk about the whole components. So in that case, how do you guys elaborate about the noise levels in case it is increasing? Like, for example, if you just want to convince a client for some larger scale units or something like that. So how do you elaborate on the noise levels?
Okay. Thank you so much. So basically, we have our finished product, which we have already the fan, we have all the filters. So for the finished product, we already measure the noise level. So of course, if you add some additional appliance or equipment, like in an area with airflow, of course, it will generate some noise. But because we are using for example, for our domestic model, we are using EC kind of motor. So that's why I believe for the noise level generated by our like system is as far as I know, it's quite acceptable. And secondly, because we cannot directly add our filter to fan coil unit, because I don't think existing fan coil unit have enough static pressure to handle our filter. Because if you're talking about like a panel type of filter, the static created by our system is similar to granular type of charcoal. So that's why if you are talking about adding our filter in some existing system, we suggest to add our filter into the like PAU or AHU, the air handling unit. So I believe if you add the filter in the air handling unit, it won't really affect the overall noise level at the air outlet, because there's already a lot of like ducting, other kind of stuff. So that's why if we do the like centralized AHU kind of modification, I don't think there is any kind of like noise impact. But the whole impact, I think if we need to do the modification at AHU, we need to check whether there's enough space, whether there's enough static available for the existing AHU system, and not the noise. But if you are considering to add some extra kind of equipment on site, so of course that will generate some kind of noise. But from my understanding, it is like acceptable.
Okay, thank you, Kathy.
Thank you so much.
Gentlemen, any questions more, or we'll have our conclusion? Muhammad Tausif, would you like to conclude the webinar?
Yes, sir. No, it's very clear. Thanks, Miss Kathy.
Thank you so much
It was
for
a very
everyone's time today.
impressive seminar.
Thank you. Thank you so
Thanks
much.
to Mr. Sunil also, and thanks to Mr. Wadi, sir.
We also
Out these webinars. Thank you, Dr. Kathy, and my special thanks to Mr. Luke, who has personally attended this webinar. Sunil, thanks very much, and Mohammad Tausif and all the admin teams, thank you very much. And to all the people who have attended, we will be issuing the certificates, and just wait for it. And if you have any questions on the webinar, you can always post so that it can be replied later by email to you. And our next upcoming webinar will be based on the chill water delta T issues, which will be carrying out in the month of November. And you have to all stay tuned for it. And it will be a very interesting webinar on the chill water delta T problems. So we have got a very a good expert who will be on the team. And I would like all of you to attend and make the next coming webinar more successful. And don't miss that one, because it is a very interesting topic. Thank you very much. Thanks all the attendees, Mohammad Faisal, Mohammad Faisal, Faisal Madani, and all the people. Thank you very much.
thank you.
Thank you so much.
Thank you.
Thank you. Looking
Thank
forward
you.
to talk
Thank
to you
you.
later. Thank you.